Students, today we would be learning how to integrate integral 0 to 1 ln of x positive root 3 divided by x squared positive 1 times dx. So foremost, what I'm going to be doing is I'm going to take x to be equal to tan theta. Differential of x would give me secant squared theta d theta. Now the limits will also get altered. Now when x is equal to 0, we would have 0 to be equal to tan theta, which means theta will be equal to 0. Also, when x is equal to 1, we would have 1 is equal to tan theta. Therefore, theta will be equal to pi divided by 4. So the original integral can now be rewritten as integral 0 to pi over 4 ln of, in place of x I need to substitute tan theta followed by positive root 3 divided by x is tan theta, so this is going to be tan squared theta positive 1. In the place of dx I've got secant squared theta d theta. Now we got a formula. The formula is secant squared theta negative tan squared theta is equal to 1, which means secant squared theta is equal to 1 positive tan squared theta. So if I were to use this formula, this is going to be equal to integral 0 to pi over 4 tan, in fact it's going to be ln of tan theta positive root 3 divided by 1 positive tan squared theta is secant squared theta multiplied by secant squared theta d theta. Now clearly secant squared theta can be cancelled, giving me integral 0 to pi over 4 ln of tan theta positive root 3 times d theta. Now I know that tan theta is equal to sin theta divided by cos theta. So because of that, this is equal to integral 0 to pi over 4 ln of sin theta divided by cos theta positive root 3 times d theta. Now taking the LCM as cos theta, this can be rewritten as sin theta positive root 3 times cos theta divided by cos theta times d theta. Now we know a formula, that is ln of a divided by b is equal to ln a negative ln b. Because of this formula, I can rewrite this as integral 0 to pi over 4 ln of sin theta positive root 3 times cos theta negative ln of cos theta. Of course we got d theta there, so place a parenthesis and place the d theta. Now this can be rewritten as integral 0 to pi over 4 ln of sin theta positive root 3 times cos theta times d theta negative integral 0 to pi over 4 ln of cos theta times d theta. Now what I'm going to do is I'm going to express this quantity sin theta positive root of 3 times cos theta as a times cos of theta positive alpha. Now my a value is obtained by taking the square root of the coefficient of sin theta, which is 1, square it, coefficient of cos theta, which is root 3, square it. So this is going to be root of 1 positive 3, which is root of 4, which is equal to 2. I'm only taking the positive value. Next, my alpha. To obtain the value of alpha, we have to use tan alpha to be equal to the coefficient of sin theta, which is 1, the coefficient of cos theta, which is root 3, and you got to take a negative sign. So this would imply tan alpha is equal to negative 1 over root 3, which implies alpha is equal to negative 30 degrees. So this is the value that we have got. So therefore, sine theta positive root 3 times cos theta can be rewritten as 2 times cos of theta positive. Now 30 degrees is actually pi divided by 6, right? So that is going to be negative pi divided by 6, which can be rewritten as 2 times cos of theta negative pi over 6. So now we need to put these things together. So this is going to be equal to integral 0 to pi over 4 ln of, in place of sine theta positive root of 3 times cos theta, I have got 2 times cos of theta negative pi over 6 times d theta negative integral 0 to pi over 4 ln of cos theta times d theta. Now this can be rewritten as, actually this is nothing but ln of a times b, which is equal to ln a plus ln b. Okay, now using this formula I can rewrite this to be as integral 0 to pi over 4 ln 2 positive ln of cos of theta negative pi over 6 times d theta. Of course, I need to place the integral sign. So integral 0 to pi over 4. So there should be a d theta there, followed by negative 0 to pi over 4 ln of cos theta times d theta. By first considering, so what I'm going to do, I'm just going to consider integral 0 to pi over 4 ln of cos of theta negative pi over 6 times d theta. Now I would take a negative sign out, so this can be rewritten as integral 0 to pi over 4 ln of cos of, I take a negative sign, so that's going to be negative of pi over 6 negative theta, right, times d theta. So this is nothing but, this is similar to cos of negative theta, which is nothing but cos theta. Now why is this possible? Because cos is an even function. Okay, even function. So because of this, this is going to be equal to integral 0 to pi over 4 ln of cos of pi over 6 negative theta times d theta. Now I'm going to introduce to you a formula, which is integral 0 to a f of x times dx is equal to integral 0 to a f of a negative x times dx. So this is an important property which is present in integrals. Now by this property I can rewrite integral 0 to pi over 4 ln of cos of pi over 6 negative theta times d theta. Now instead of a I've got pi over 6. So this is equal to integral 0 to pi over 4. If you are going to be removing the a, you will get the function back. So this is going to be ln of cos theta times d theta. So if I were to mention this as equation 2, then I can rewrite this. So therefore 2 is rewritten as integral 0 to pi over 4 ln 2 times d theta. You got to bring this in, so it's going to be positive integral 0 to pi over 4 times ln of cos theta times d theta negative integral 0 to pi over 4 ln of cos theta d theta. Now clearly these two can be cancelled, so thereby giving you integral 0 to pi over 4 ln 2 times d theta. I can rewrite this as ln 2 times integral 0 to pi over 4 times d theta, which is equal to ln 2 times integral of d theta is going to be theta 0 to pi over 4. This is going to be equal to ln 2 of pi over 4. Substitute the upper limit, negative 0. This can be rewritten as pi over 4 times ln 2, which is the final answer